Our next example is a problem where we've got everything on one side and it's equal to 0. So that's good. We don't have to move any terms around. And it's got 4 terms that don't have a greatest common factor. So remember, when you've got 4 terms, you want to think of factoring by grouping. We're going to group the first 2 together, group the last 2 together, and factor out the greatest common factor from each group. So for 3x cubed and x squared, we can factor out an x squared from each one of those. And if we divide each one by x squared, 3x to the third divided by x squared is 3x. X squared divided by x squared is 1. So we have x squared times 3x plus 1. For that next group, for 12 and 4, you could factor out a 4, but remember something we talked about when factoring by grouping. If that second group starts with a minus, you have to factor out something negative. So here, we're going to divide both of those by negative 4 to see what's left over. Negative 12x divided by negative 4 is 3x. Negative 4 divided by negative 4 is plus 1. So now we take that 3x plus 1 and put that at the front. From the first part, we have an x squared left over. From the next part, we have a minus 4 left over. And all of that is still equal to 0. Now here's the thing that's different than our other factoring by grouping parts that we've done so far. We can't do anything with the 3x plus 1, but we actually can factor the x squared minus 4 a little bit. That's a difference of squares. The square root of x squared is x, so we put an x at the beginning of each group. The square root of 4 is 2, so we put a 2 at the end of each group. We stick a plus in one parentheses, a minus in the other one. And now we've factored it as much as possible. So having done that, we can break it up into 3 smaller equations. 3x plus 1 equals 0, x plus 2 equals 0, x minus 2 equals 0. For the first one, we subtract 1 from both sides, and we would have 3x equals negative 1. And then divide by 3, we end up with x equals negative 1/3. The next one, you subtract 2 from both sides, you would have x equals negative 2. The last one, you add 2 to both sides, you get x equals positive 2. So we ended up with 3 different answers for that equation. Let's try one more. Here we have 3d to the third minus 6d squared equals 24d. Well, we want to get everything on one side so it's equal to 0. Here's our highest powered term, and it's already positive, so I want to move everything to that side. So I would try subtracting 24d from both sides. That leaves us with 3d to the third minus 6d squared minus 24d equals 0. And now we can try to factor it. So first thing you always look for before you start trying to split it up into 2 parentheses, you see, is there a greatest common factor? Now 3, 6, and 24 are all divisible by 3, and we've also got variables in all of these terms, and the smallest power of the variable would be just d to the first, or d. So to see what's left, I'm going to divide them all by 3d. 3d to the third divided by 3d is d squared. Minus 6d squared divided by 3d is minus 2d. And negative 24d divided by 3d is minus 8. Like that. Now that's not quite done factoring. We leave that 3d out front. The greatest common factor doesn't go away, but we can factor that next parentheses some more. So here we want to think, what can we multiply to get a negative 8 that's going to add up to a negative 2? Since it starts with d squared, we'll put d at the beginning of each group. Now to multiply to be negative 8, but add up to negative 2, you would need a minus 4 and a plus 2 to get it to work. And now we're done factoring, so we can set each factor equal to 0. 3d equals 0, d minus 4 equals 0, d plus 2 equals 0. The first one, to get the d by itself, you divide both sides by 3, and you would end up with d equals 0. The next one, you add 4 to both sides, you would have d equals 4. The last one, you subtract 2 from both sides, you would have d equals negative 2. So we ended up with 3 answers for that equation.